This is the San Jose State ME110 product case study of the Toyota Yaris transmission by Andy Wu, Jeffrey Chow, Carrie Geldreich, and Aaron Chen. This is the transmission housing. We believe this is made by die casting because of its complex geometry, rough surface, and parting lines. An alternative to die casting would be sand casting for its low tooling cost, but with the sand casting it would be difficult to achieve this complex design. After the part is die casted and is machined, you can see where it has been machined by the shinier surface and scratch marks. After the part is machined, screw holes are drilled out and threaded. This is the transmission case cover. We believe this is made by sand casting because of its simple geometry and rough surface. Alternatives would be forging or die casting. However, they are more costly and forging would make the part too heavy. In this picture, you can see the rough surface left from the sand casting. These are shifter forks and are usually manufactured by lost cast waxing since it allows for even material density and complex geometries. However, we think these were die cast because of the parting lines, and die casting allows for more material strength.
The metal gears in the transmission were most likely shaped into gear blanks by automatic hot forging due to its rough surface finish and high density. Post-processing includes turning on a lathe and hobbing to cut the teeth. Alternative production methods could be casting but would yield low strength, or milling but would be too time-consuming. This is the speed sensor gear made out of a plastic material. We predict that this is an injection molded part due to the ejector pin marks, complex geometry, and smooth surface finish. Post-processing is not needed. Alternative production methods could be casting or 3D printing, but both of these processes yield slow production rate for this widely used part.
The brackets, gear spacers, and C-clips are made from sheet metal and are manufactured by stamping. This is indicated by the clean-cut edges and the line of buckling material at the center of the cut. This bracket also has an added bending process which is indicated by the buckled material in the crease at the 90-degree angle bend. An alternative process for these parts would be hydroforming. This reduces weight and maintains material thickness. However, there would be a slight loss of material strength.
The shifter fork shaft is turned on a lathe to ensure uniform roundness and smoothness. The smoothness is an indicator of this process. The notches on a shaft are broached because it can be done quickly, making it a good option for the manufacturer. Threads are created using a thread tap. Shafts can be casted but will have to be machined for a smooth surface. The bolts are formed by cold forging process. The bolts are not casted because there are no casting lines. The head of the bolts can also be hot forged and the threads could be formed using a thread chase. However, by using a cold forging process for the bolts, it will be more efficient and productive because hot forging is a longer process.